Okay. Good morning, everyone. How are you doing today? Good morning, online. Good morning. Okay. So, did you guys complete your practicals? Everyone? Let me see your faces. Yes? Done? How about you online? Good. Okay. I'm setting up the cluster. Okay. And then let's wait for the cluster to be up. Okay. So, I hope you have completed all the practicals, yesterday's practicals. And today, let's go to something called Heapster. What's that? Heapster. So we can say Heapster, or in normal language, people call it as metric server. What's that? Metric server. So when we talk about the metric meaning it's all about what? Monitoring. Yes or no? Metric is all about what? Monitoring. So here, if you want to monitor the overall health and performance of your Kubernetes cluster, and if you want to the metric server mainly be used for auto scaling, which were, so till now we have scaled out and scale in manually, right? We have scaled out and scale in manually, but today we will set up using what? Auto scaling. We will have the same deployment we'll do, and then on that deployment, what we do the auto scaling. So if you want to do the auto scaling, we need to use some metric or not. There also in AWS, if you want to scale out and scale in, we use a metric called CPU utilization. Yes or no? If average CPU utilization is going greater than 70% or something, you wish, automatically scale out, scaling will happen or not. So here also in Kubernetes, once you create a deployment, of course, if you want to create a auto scaling, You need to have first of all deployment or not. Without deployment, can you create any auto scaling? No. So for that, first we create a deployment. On that deployment, what we do, we set up a auto scaling. We'll mention if the CPU utilization is going greater than 20%, scale out maximum to these pods, we will say. And automatic, what will happen? Pods will scale out. When there is no traffic or no load, automatic, what will happen? Scale in will happen. So if you want to do all these things, we use this concept called metric server. What is that? Anything related to monitoring. So we need to use what? Metric server. And by default, we don't have metric server in the Kubernetes. We need to install that metric server. Right? And also someone asked Kubernetes dashboard, GUI. Right? So in our previous classes, they asked, like, do we have any GUI for Kubernetes? See, for Docker also, we had a GUI. What was that? Portainer. Which one is that? Portainer. So Portainer is a GUI for the Docker, and Jenkins is obviously a GUI. And next here we have for Ansible. You don't remember, but Ansible till Galaxy we learned. That topic we haven't learned because it's a license based, right? What is the topic? GUI for Ansible. Ansible Tower. What is that? Ansible Tower. So Ansible Tower is to manage all your playbooks and everything. And here for Kubernetes also, generally we go, see, in Ansible everything we went through command prompts only. For Docker also we went through the commands only. For Kubernetes also we'll go with what? Commands only. But just in case if you want to see the dashboard, so you need to configure the dashboard separately. So that is the task for you for this weekend. Is very straightforward. If you just Google it or ask ChatGPT, so a couple of manifest file, one manifest file it will give, which is to run and do some role bindings. We need to give permissions for that. Very interesting. So I'll give that as a, please remember that is a task for you to set up what? Kubernetes dashboard. First you set up the cluster and complete all your practicals, and then you set up this Kubernetes cluster. Okay. So this main features for this Kubernetes metrics is two things, Nana. Number one here is, we call it as auto scaling, but here we have a name called HPA. What is that? What is HPA? Horizontal pod auto scaler. Say that. Horizontal scaling meaning what? Scale out and scaling only, auto scaling, right? So here we call it as HPA. What is that? Say that again. What is HPA? Horizontal pod autoscaler. There is also something called VPA. What is that? Vertical pod autoscaler. You tell me which one is suggestible to go for. Horizontal or vertical? Horizontal only, right? To remember horizontal scaling, vertical scaling in AWS. Horizontal scaling meaning auto scaling, scale out, increasing the number of machines. Whereas vertical scaling meaning scale up. That meaning you are increasing the capacity of the server. Yes or no? Here pods are created. Will you increase the capacity of the pod? Or will you create the new pods? Horizontal scaling is always best. But here we go with the HPA. But in very rare cases, people go for what? That VPA. So HPA by default metric server will provide. VPA will not be provided. So for that, you need to do something advanced level, like, install CRDs, custom resource definitions. We need to install, set up VPA and increase the size of the pod. Pod is also using the memory and CPU or not, right? You need to vertically increase it while it is running. So instead of that, we'll go what here? HPA, horizontal pod autoscaler. And this metric server will help you to set up HPA and Kubernetes dashboard. So what are the key features of this metric server? So what it does, Nana, here see, key features is resource metric. What is that? Resource metric meaning it collects CPU and memory usage metrics from the kubelets. Where are the kubelets available? in worker nodes. In worker nodes, who is the agent? No? Kubelet is the agent or not? So kubelet is the guy who will get all the information. It will collect this resource matrix, will collect this CPU and memory usage from whom? Kubelets, and provide aggregated metrics at the node and then pod level. Node level also it will provide the CPU memory, and the pod level also it will provide the CPU memory. Which one will collect all this information? Resource metric. Auto scaling, we don't even talk about it because you know about auto scaling a lot, right? Whenever there is a load on the CPU and memory, automatically what will happen? Scale out will happen. Auto scaling will happen. Next is dashboard, as I said. So dashboard meaning using the dashboard, you can create pods. Using the dashboards, you can create services, everything. Whatever that you want to set up, you can do it using the Kubernetes dashboard. So kubelets are the guys which will collect the entire information, give it to the whom? Resource matrix. Matrix server will do. Okay, so how to set up a matrix server? Simple. There is a YAML file already available, right? There is a YAML file already available. Let's go with that YAML file. So most of the time, guys, these YAML files we are taking from internet. Sometimes what happens is, this is from GitHub, Kubernetes, repository. Inside that we have something called matrix server, and they'll keep on releasing the latest versions, and then this particular version. And sometimes what happens is these URLs might not work, because end of that is an internet URL, right? So for that you need to just find out what is the exact URL. Let's see whether this works or not. So probably it should work, but this is not working. Okay. Voice breaking. Voice breaking online. Can you hear me? Kiran, check your 1.5 GB. So meanwhile, let's learn some commands here. See, once you run this, what will happen? It will install the metric server. Once you run this, what will happen? It will install the metric server, and you need to wait for at least 2 minutes, because it need to collect the entire information from all the nodes and pods or not. So what is the command to see? What is the command to see all the CPU and memory information about your pods? kubectl top pods. Remember in Docker also we use a command called top, right? To see the memory and CPU information about that. So here also we have what? kubectl top pods. And if you want to know about the nodes, kubectl top nodes. kubectl what here? Top nodes. Still working. But do you have the problem with pending? Okay. So very soon it should work. Okay. So I think all three are true now. So I think it should work in a few seconds. So what is the command to see the status? To list the cluster, kops, get cluster. Okay, how to list the nodes? kubectl get nodes. Everything is ready, but it shows error. Let's see. Because sometimes when you are setting up the cluster, inside that few in kubesystem, remember kubesystem namespace is there, no? Inside that very important API server schedulers, and sometimes if those pods are not created properly, then you get this kind of errors. Okay, let's see. If not, we'll destroy this and then recreate another pod. Let's see how it works with the metric server now. Okay, so for now I can say this. So what we do now, let's go and install what? Metric server. How to install it? Take this YAML file and go ahead and then install. So just now it is installed. Once it installed, at least we need to wait for how many minutes? Wait for 2 minutes. So what's the command to see? kubectl top pods. So what it says? So it is server is currently unable to handle the request. Let's wait for a couple of minutes because it will take time to set it up, right? So kubectl top nodes also. So meanwhile, let's move on. So we will be setting up what here? HPA. What's that here? HPA, horizontal pod auto scaling. So based on, it will scale the number of pods based on CPU memory utilization. There is also something called what here? VPA. So it will adjust the CPU memory request limits of the pod dynamically to improve resource allocations, right? So if the pod is running, and we will be talking about the resource management also. Remember in Docker also we used resource management. So we allocated a particular CPU and memory for the Docker container or not. Similarly here also we can allocate, right, for the pods, particular CPU and then memory limits. So you can increase those limits using this VPA. But as I told you, by default this VPA is available? No. So you need to install a separate some custom resource definitions in order to use that what here? VPA. But here which one we should be using it? HPA. Which one are here? Okay, now it's good. And do you see this here? So kubectl top pods. Are there any pods here at the moment? No. So then if you go for kubectl top, which one? Nodes. If you take the nodes, do you see this here? So this node is taking here how much percent? 10%, and this much memory, right? This much memory is taken here. So, and this is, I think worker nodes 5% and then 2%. So if you want to see the memory and CPU information, so then you need to install what server? Metric server. What server here? Understood? Installation of metric server is just running a command and wait for 2 minutes and automatically you get the CPU and the memory information. If you have the pods, we don't have pods at the moment. If you have the pods, kubectl top pods, and then we'll get the pods memory CPU information also. Okay. So now as our metric server is ready, so what we do, let's go and do the deployment first. And on top of the deployment, what we do? We'll do the auto scaling on it, right? So I'll take the same, this one here. So VI, I call it as auto. So what is the deployment it is using? MB deployment. So here there is also one more for me. Okay. So trainer here / mobile banking. What was that? MB hyphen image. Okay. So, and how many replicas are there here? 3 replicas. Okay. Now let's go and set up kubectl create hyphen f auto.yml. So deployment got created. So kubectl get pods. How many containers is getting created here? 3 containers. So it is still creating. Hmm. What happened? Container creating still. So these are all issues because of that cube system. One of the part didn't create it properly, right? Come on, baby. Okay. It took time. So, but still, okay, it's working. So now what's the command to see the CPU memory information about the pods? kubectl top pods. So do you see this here? Why it is listing only 2 pods? We had 3 pods, right? Replicas. Okay. Oh, so now it is listing. So that means we need to have some patience today. Okay. So now do you see this here? Because why it got delayed? There is a reason behind it. No. Every time we should not put it on that. Okay. So because metric server will take time, no, to gather the information. So metric server gather the information about the 2 pods immediately, and it is gathering. That's the reason why it took time. So now do you see this here? So here I'll talk about what are these cores and all CPUs, and then this is the CPU information, and this is what here memory information you have. So one CPU is equal to how many milli CPUs? Okay, now let me ask like this. 1 liter is equal to how many milliliters? 1000, no? So one CPU is equal to how many milli CPUs? 1000. Okay, nice comparison. Right? So here also it is using only here 1 milli CPU. 1 milli CPU out of 1000. One CPU is equal to 1000 milli CPUs. Inside that, a pod is using only 1 milli CPU. So very light or not? 0.00 something, right? Okay, so now it's good to go and open the watch command because it needs to auto scale, right? While it is auto scaling, we should see that. Damn it. Okay, sudo hyphen I. What's the command? kubectl get pods hyphen watch. Watch. So now these 3 are there. Now let's go ahead. There are, see, by the way, in Kubernetes, I told you imperative, declarative. You can go for sometimes imperative also, sometimes declarative based on your requirement. It doesn't mean that all the time you go for declarative, all the time you go for imperative. Whenever there is a requirement, just go ahead. That's as simple as that. So, but if you want to reuse, all the go for declarative. Reuse meaning here what we use, manifest files we use. So here, now I am using a command to create a auto scaling here. So say with me here, kubectl auto scale. Say that. What's the command here? kubectl auto scale deployment. Which deployment you want to auto scale? MB hyphen deployment. So hyphen CPU hyphen %. So %. How much CPU % that you want to put a threshold value here? Let's put 20. Huh? Okay. CPU percentage here is 20. Right? Do you need to use memory also? Only one CPU is enough or not? Yes or no? In AWS also we go with the average CPU utilization. Only one metric. Right? Here we have it. And then in this group, how many minimum you should have? 1. Maximum how many you should have? For example, 10. Observe that comment. You understood the comment? Hmm? So kubectl auto scale. So obviously tell me, guys, remember you need to auto scale which one? Deployment. Without deployment, what do you auto scale, right? kubectl auto scale, deployment, MB hyphen deployment, and what you need to put? Hyphen CPU hyphen percent. How much percent is here? 20%. So whenever this deployment is going more than 20% CPU utilization, automatically what will happen? Pods will get created. Maximum of how many pods it will create? 10 pods. It's up to you. You can change it to how much ever you want. So here at the moment, I'm just going for what? Maximum 10. So now what it says? This is what? This is the API version or not? So here horizontal pod autoscaler dot autoscaling slash, and this is the deployment got what? Auto scale. So auto scaling got created or not? So I have created using the command. So same thing you can create it using the manifest file also. Manifest file you need to write this much big. So here this command is really nice, right? So you can, I'll show you, like you can your practice. I'll just give you manifest file also. You can do it that also here. Okay, can you tell me what's the command to list the HPS? kubectl get HPA. HPA meaning horizontal pod autoscaler. So do you see this is my HPA name, right? And do you see this is the reference of the deployment? Okay. And then how much percentage it is using now? 1% out of. So now it has set the threshold value or not? Threshold value is how much here? 20%. So now the entire utilization is only 1%. Now will it auto scale? No, it will not auto scale. How many minimum pods here? 1. Maximum pods? How many replicas are there here? 3. So now auto scaling got created. If you do it again, how much percentage you have? Only 1%. And how many pods are running? Only 3 pods. Auto scale will happen now? No. So for that, what we need to do now? We need to stress the pods or not? If you want me to show you the auto scale out. So the pods should get stressed. The CPU utilization should go more or not? Then, so if it is going more than 20%, then what will happen? Automatically scale out will happen. So for that to show you, I got some few commands. So it will be interesting for you to stress the CPU, stress the pod, and whereas the CPU utilization will go more than 20%, and then in this watch command, automatically new pods will get created. Should we do it now? Okay. So what's the command to get the pods? kubectl get pods. Let's take one of the pod and we'll try to log into the pod. Tell me the command. kubectl exec hyphen it. Let's take the pod name. Okay. Hyphen bin bash. As I told you, you can go for sh. Sometimes you can go for bin bash also. Depend upon the shell it is using inside the pod. So now I go inside it. I'm inside the pod or not? As it is the Ubuntu pods. So what's the first thing that you need to do? Apt update. Okay. App update. And there is a package called apt install stress. What is that? Stress. Stress is a package available for stress purpose, but don't install in your brains. Okay, should always stress free. So there is a command on here to stress it for how many seconds? 60 seconds. How many seconds here? See the stress hyphen CPU. How many CPUs you are stressing here? 8 CPUs. And here also we have something called IO, input output. So here in your input IO ratio, your IOs also is getting stress for 4 levels. And then your VM, your virtual memory stress is also getting increased. And bytes is this, and timeout is for 60 seconds. This is just a stress command if you want to stress any of the machine. And what will happen if I stress this now? So I'll stress it for 60 seconds. Do you see this here? Fadak, it just launched just like that or not? See here, auto scale happened. Is it automatic or not? So I'm just simulating that my application is getting used and the CPU utilization has been increased. When the CPU utilization has been increased, what will happen? Automatically scale out happen. And now the stress will be there only for how many seconds? 60 seconds. After some time, what will happen? So scale in will happen automatically. Instead of showing you from the application point of view, I manually stressed it, simulated it. Online, is this clear now? So it successfully completed 60 seconds, right? See, all the things are happening. I'm exiting from it. So what's the command to list the HPS? kubectl get HPA. Wow. What is this here? 118%. How much I have given? Only 20%. That powerful stress command or not? Don't use that in real time. Don't use it. Will you use it? If you want to pull your manager's leg, what you do? Log into one part. This is the weapon. Use this stress command. Automatically, what will happen? Pods will get created. Thousands of pods will get created in real time. But yeah, so this is the actual. Now, what is there here now? 1% because the stress has been reduced or not. kubectl get pods. Slowly, it will now remove all the pods because now it is stress. I mean, CPU utilization is less than 1% now. Clear now? Auto scaling. So, kubectl top pods. All are using 1 milli only. Okay. Now, kubectl describe. Say that. kubectl describe HPA. What's the HPA name you have created? MB deployment. So if you use this, it will show all the scaling activities here. So new size previously is, and now previously the size was 10. Now it has reduced to 7. Now it has reduced to 5. What is the reason for it? CPU resource utilization percentage is above the target. So here, by seeing the describe option here, HPA, it will understand. Now at the moment it is only 1%, right? Maximum here it will show all the information about your HPA. Clear? So there is also one important command. Please remember when you're working on Kubernetes, get events. Say that. So if you want to, what are the events that is happening inside this? It will show you everything inside this. Remember, if you see any, if you want to see the logs of the, and if you want to see what are the events happening in the cluster level, so everything you can see it using this command. Very powerful command, very useful command. What's the command here? kubectl get events. So what are the events that is happening? Everything it will show you. Okay, online. And if you want to see a particular log, particular pod log, so what's the command? kubectl logs, and then just put the pod name. So it doesn't have any logs at the moment. Okay, after a few minutes, automatically metric server will take time and then it will scale in automatically to the, again, how many replicas? Only 3 replicas. Clear on the auto scaling? So how to delete? kubectl delete -f. Super. Got deleted everything. It is terminating all. Okay. Okay. So that is what here we have. And I gave you one example for you while practicing for weekend. So you create a deployment again. I've just deleted, create a deployment again, right? And then I have given a manifest file here for the auto scaling. You can use what? Command also, or you can use the manifest file. If you use the manifest file, what's the API version we are using here? Auto scaling / v2. Remember this, because if you are interested in writing the Kubernetes certification, then these are all the things are important. Just want to ask, anyone interested? First complete your AWS solution architect and then go for Kubernetes when you have time, right? So it's not mandatory as for the freshers. So no one will ask about this DevOps Kubernetes Terraform certification. But if you have it, you are superb. It's just like you are most preferred all the time. So what's the kind here I'm using here? No. Horizontal pod autoscaler. So this is what is the name I'm using? Autoscaler name IB-HPA. Specific scale target reference. Scale target reference. So here API version, we need to use a deployment or not? Without the deployment, so here we have created the deployment, right? What's the name of the deployment we created? IB-deployment. That you need to reference. What's that here? Reference. Say with me here. Scale target reference. Acha. I was not ready for that. Okay, scale target reference. And then API version is apps/v1. Kind is deployment and name is this. And then do you see how many minimum replicas here? 2 and maximum here 10. But in the command, I put the minimum as 1 and maximum 10. You see your wish here. And metrics, we need to provide the metrics or not. In the command, what we have to mention? -, CPU -%, right? So here also type, what is the resource? What is the resource name here? And the target type is what? Utilization. What is the average utilization here? 20. So this is the huge thing that you need to write while in the manifest file. Write in the command, single line. Because if you are the guy who is handling the Kubernetes in your company, you can run it the commands because you are the only one who is doing. But some people might know Kubernetes, some people might not know Kubernetes. Some people, let's say for example, I'm there handling it, right? So some name. Harsha, right? So Harsha is also working with me, for example. I went for a vacation. Harsha doesn't know Kubernetes. What I'll tell? Should I tell the command to run, or there is a manifest file readily available, run this command? That's it. So if you want to reuse it multiple times, then go for the manifest files. So both works the same thing or not? So that's the reason why I'm giving you command also, manifest file also. Okay, Nana? So same thing, Kubernetes, kubectl apply and get the pods and then log into any of the pod, and then what you do? Stress it, and then you see whether it is working or not. So if you want to delete, how we have installed using apply? Simply you put what? Delete. Clear? Online, is this clear on the auto scaling HPA? Nice. Okay. So next what we have is what? Resource quotas. Say that one here. Resource quotas is similarly resource management we have done for the Docker containers, right? Similarly here also we can do the resource quotas, because here, remember we already completed namespaces concept, isolated environment for the users, right? So I created a namespace called dev namespace or prod namespace. These developers, what they do is they are creating thousands of pods, hundreds of services, and then they are eating all my resources of my host machine. End of the day, this is working on the EC2 instance only, right? What is the EC2 instance memory? I has only 1 GB. Assume in real time, I might be having some 32 GB, 64 GB, but most of the time my GB, memory and CPUs are utilized by dev namespace. What I need to do for that? Should I go and tell to these guys, developers, don't create the parts, don't create the parts. You have only this limit. Please create only 10, 100 parts in you. Is it possible for me to tell? They'll write some one piece file and then replica, they'll put 1,000 and then done. Yes or no? So now what I need to do? I need to restrict them or not? I need to give them the quota. I need to give them what? Quota. So I will say that, hey, dev namespace, you can launch only, let's say, 5 pods in your dev namespace. And that too, I am giving for the dev namespace only 1 CPU and then this much memory limit. So if they try to launch the 10 pods, will they able to launch it? Answer is no. So in real time, sometimes you need to do the restrictions like this. You need to set the quotas for the namespaces. So by default, when you don't put any quotas, what will happen is pod will take your maximum memory, maximum CPU. It will reach up to maximum. And remember in container also same thing, right? So container, it is taking 1 GB RAM or not? On that I showed you. Top command, right? So the limit is maximum. But is it good to set the maximum limit to the maximum of your CPU and memory? For that reason, here you set up the name, you create a namespaces and then set the quotas for it. Request limit for it. Request meaning how much we need. Limit meaning how much maximum they can do it. So the default, okay. So here, what we do is, we will go and create one namespace called dev. Okay, I'll not show that commands to you because you remember those commands, right? Let's go and create a dev namespace and then we will switch to the dev namespace. And then what we do, we will set a quota for the dev namespace, like saying that pods are only 5 and the limit of CPU is only 1 and then memory is 1 GB, for example. We'll set the quota like this and then we'll try to run some deployment, putting the replicas as many. Will it work? It should not work, right? Should we do that? Nice. So let's go and create a dev namespace. Come on. So this is dying. Let me close this. Okay. Tell me, Nana. kubectl, create namespace called dev. Okay. Switch it. kubectl, config, set hyphen, context, hyphen, current, hyphen. Super. How to see whether your config view, kubectl config view. Everyone able to remember those commands? If you practice multiple times, you can able to remember all those commands. I'm telling you, Nana. Okay. Okay. So now let's go and create one dev quota. Dot IAML. Okay. So what is this here? API version. Which one? V1 for this. Kind. Resource quota. What's that? Resource quota. And then what is that? Metadata. What is the name of the resource quota? I call it as dev quota. Dev quota. And to which namespace you are assigning this? Dev. And then what we do here? Spec. Inside the spec, I am putting the hard limit. I'm putting the hard limits called pods. How many pods? For example, it's my wish or not? Is mandatory to put only 5? No, it's up to you. Like next year, limits dot, which one? CPU. So how many CPUs? 1 CPU. And then limits dot, which one? Memory. And how much GB? 1 GB. So I'm setting this like this. And then let's create it. So what does the manifest files will say, Nana? Pod meaning a maximum of 5 pods can be created in which namespace? Dev namespace. And then CPU limits maximum 1 CPU. And then maximum memory, it will limit up to only 1 GB. Let's go for it. kubectl create hyphen F. Which one? Dev quota. Quota got created. Now this quota got applied to the dev namespace. So whenever you want to create a pod, definitely you need to mention the CPU and memory. Otherwise, you cannot create the pod in the dev namespace. Can you tell me how to list the quotas? kubectl get quota. So it clearly says dev quota. How many pods here? Maximum 5. But how many are running? 0. And what's the limit? CPU limit 1 and memory limit 1 GB. Are there anything here at the moment? No. That's a quota I have set it for which namespace? Dev namespace. Now what we do? Let's, can you tell me one imperative command to create a pod just like that in this? Okay. Next, kubectl run. Let's say for example, pod1 hyphen image is equal to nginx. Will this work? Will this work? Online. Yeah. No, this will work. This command will work. Syntax is okay, but this will work. This will not work because why? I'm in which namespace now? Dev namespace, no? So in the dev namespace, I have put a quota called CPU 1 and the memory is 1 GB. So when you are creating a pod, must and should you need to mention the CPU and memory details. Otherwise, pod will not get created. Do you see what's the error it says? Pod 1 is forbidden. Failed quota. So that meaning dev quota here must specify limits of CPU and then memory for the pod 1. So it cannot be created just like that. So we are forcing the dev namespaces or developers, if you want to create the pod, mention the CPU and memory. If it is going more than our limit, it will not create the pod. Okay. So now let me take an example here. Okay. So now ls okay vi deploy dot yaml. See here. Tell me what is doing. See this diagram and tell me. Will this work or not? How many pods will get created? I'm asking, see that carefully and tell me the answer. Small logic, think, answer will come. If I tell the logic, Patak, you will say answer. Someone say 1 pod, someone say 3 pods, someone say 4 pods. Deepali. So 4 is possible. The replicas, how many mentioned? 3. So each okay. Okay, let's go and run this. So do we have any pods here at the moment? No pods, right? Okay. Now let's go and run kubectl create hyphen f. Which one? Deploy. Hmm? 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 Sir, what online people? Sir, what happened? What happened? Okay, let's see. How many pods? One pod. Why? So it will take time and okay. So why it will? Because we have mentioned how many CPUs? One CPUs. The limit is one CPU. But in the manifest file, how much you have mentioned here? One. So one is done, no? Yes or no? The quota is how much? One CPU. Quota is one CPU. Here also you are putting the replicas as 3. And each, so that meaning, and the memory also how much GB we have given? Only 1 GB. If it is then meaning if it is only one replica is getting created, 512 MB will get created. If two replicas meaning it is going more than 1 GB or not? Yes or no? And the CPU is also going more than one or not? So for that reason, only one got created here. Okay. So now let's delete it. kubectl delete hyphen f deploy. Deleted. Now what I need is I want all 3 to be created. So in that case, what should I modify? You tell me. CPU, how much I need to put? How much? 0. Got it, Nana? Online. And then this one? Huh? 333 or 300? Now it will work or not? So all 3 will get created or not? Online. Clear, Nana? So now let's go kubectl create hyphen f deploy.map. So and then if I say kubectl get pods, so all 3 got created. Got it? This is how you limit the namespaces. Nice concept, no? So because in real time, all these nasty things will come all the time. These people will come and say, hey, we cannot stop the people. Remember, we have multiple teams. How many times will you go and tell them? How many times will you go and tell them? We cannot stop them. For that reason, what we do? In the back end, cut it. And then 1,000 people comment and shout it on also, you also, nothing they can help. You cannot talk. So instead of you talking to them, let them talk to you by doing like this. Good. Okay, so let's delete this also again. Is this clear now, everyone? On the resource quotas? Clear? Online? Okay. So next concept on the Kubernetes is volumes. What's that? Volumes. We did the same thing on Docker. Remember? So we created the volumes inside the host machine. Guys, we created the volumes inside the host machine, and then we have attached that volumes to the Docker containers. In real time, we will decide the limits for namespaces or any requirement. For Kubernetes, we'll go with the namespace because these are all isolated environment for the developers or not for the users. Yes, Deepika. And what was that? Volumes. Yeah. In the Docker also, we created the volumes in the host machine and then we attached to the Docker containers. And also, what happened if the host machine goes down? All your data is gone or not? For that reason, what did I show you? EBS volume. You tell me, is it better to go with the host machine volumes or EBS volumes? In the Kubernetes, let's go with the EBS volumes. But if required, can you create it from the host machine also or not? But I'll be showing you with EBS volumes, which is the advanced one, and then which is the most commonly used in the real time. So what is the whole concept? Here we have something called, here we call it as persistent volume. What's the name we say? PV. Say that. Say that. PV. What's the PV meaning here? Persistent volume. What is that here? Persistent volume. We have a concept called stateful, stateless. Say that. Stateful and then stateless. So stateless meaning what, Nana, here? If you delete the pod, the data is completely lost. Stateful meaning if the pod is deleted, the data is still available. Stateful, stateless. Don't get confused with security groups. I know when you put that feeling, I understood. Right? Security groups, that is different. Security groups are state. I told you one hint also, right? Security is always full. Right? Security is state full. Which one are stateless? NAGL, NACLs are stateless. Okay, let's not, please don't compare with that AWS stateful and stateless. Let's concentrate. Here, stateful, stateless is all about the data. So whenever you delete the pod, if the data is also getting deleted, that is called stateless. That means less meaning data is less. Stateful meaning data is full. That meaning the data is still available. So in Kubernetes, we have this concept called stateful and stateless. What's that? Stateful and stateless. Which one? Whatever that we are doing till now is stateful or stateless? Stateless. Which one? Stateless. If the pod is deleted, the data inside the pod is also getting deleted or not. So whatever that we have done till now is stateless. So now we need to concentrate on stateful. So by default, it is stateless. Now we need to go and do what? Stateful. Let's concentrate on now stateful. So what we do is here, this is your cluster. This is your cluster. Kubernetes cluster. This is the volume. Guys, I'm directly going for the EBS volume. Instead of creating volumes in the host machine, we can get directly because this is a real time that we use. So let's go and create a volume of how much GB? 20 GB. Enough, no? Because unnecessary we'll get the bill for it again. So 20 GB, that to go for magnetic. Okay, magnetic. You can go for magnetic or GB to GB3, your wish. Right? Don't go for I1, I2 because AWS will take revenge on you. Okay, so this is the volume that we create in the AWS EBS volume. Listen carefully. So these are the pods that we have. Here we have the pods. So this is called PV. Say that. This is called, what is PV meaning? Persistent volume. So we need to use this PV to our pods or not? Yes or no? So if I use the PV 20 GB, only this 20 GB, everything will get here in the single pod, but I want to share it on all the pods. So what we need to do is we need to create what? Here, PVC. What we need to create? PVC. Persistent volume claim. Say that. Persistent volume claim. We call it as PVC. So from PV, we create PVC, and this PVC will be attached to the pods. Okay, and this PVC what? And no, this PV is bound to this PVC or not? What is the word I'm using here? Bound. So these are all the pods. So every pod will have this PVC claimed. So indirectly, this volume is attached inside the pod. Just in case if pod got deleted, as we have a self-healing mechanism, one more pod will get created or not. As the data is stored inside the volume, so if the pod is deleted also, new pod will generate it. As the volume we have attached is using this PVC concept, the data is still available here, not on the pod. This is called stateful. What is this called? Online got it, Nana? This is called what? Stateful. So this PVC will take the volumes, will take the data, will take the storage from the PV, and then it will get distributed to the pods. So can you use directly PV here? No. So for the pods, you need to use only PVC. Remember that. No, got it? So I'm showing from the external EBS volume, right? So there is also something called storage class. Say that. Don't get confused with S3 storage classes. So this is the storage class. This is, if you are not using the external EBS volume, in your host machine, you have the hard disk or not. So this pod will dynamically take the storage info. Dynamically take the space from your host machine using the storage class concept dynamically. But which one is better here? We'll go with what here? EBS volume. So if you have a physical storage, that means EBS volume, you need to create a persistent volume. PV you need to create. From PV you need to create what? PVC, and that PVC you need to put it inside the pod. What is the hierarchy? Tell me here. EBS volume. EBS volume is a persistent volume. So you have EBS volume. From that EBS volume, create a PV. Of course, EBS volume in AWS will create it. That's a volume. From that we create a PV, and then from there we create what? PVC, and that PVC will be used in the pods. Volume is just a volume, no? In Kubernetes, how does volume will be understand? For that is in Kubernetes, we'll create what? PV. Volume will be there, right? And then we'll create a PV, and then we'll create a PVC, and then that PVC will use it in the pod. So just in case if the pod got deleted also, automatically what will happen? It will self-heal it, and then the data will also available inside the volumes. Clear? Online? Concept is clear now? Stateful, stateless. So what we do first? We will go and create one volume or not? You know how to create a volume? Let's go and create a volume. Ooh. Do you see? That's why I told you EBS, this cluster, Kubernetes, 64 GB, 20, 120, 128 GBs, right? We are looking only for 10 GB, 20 GBs, but you see Kubernetes is creating, KOps is creating all these things because it has a database, right? etcd and all. So let's create our own volume. Let's go for magnetic. How much GB I'll go for? For example, 20 GB. Enough, no? So I'll go with what? 1A. And okay. Where is the 20 GB? This one only, no? Standard. I call it as persistent volume. Okay. So we need to copy this volume ID because we need to use this volume ID in the manifest file to create PV. To create what? PV. So meanwhile, what do we do? Let's go and delete our namespace. So what's the command to delete the namespace? Delete ns dev. And then switch it to default. Because we were in the dev namespace, right? How to switch to default? kubectl config set hyphen context hyphen current hyphen namespace is equal to default. So let's switch to default. So kubectl get plots. So we don't have any plots, we are clean. Okay, now let's go and create a PV. What we need to create first? Louder. What we need to create first? PV. Do you see this here? Let's create a PV. Listen carefully. PV.yml. Okay, see here. What is the API version we are using here? V1. What's the kind? Persistent volume. We have been using the kind, so many kinds till now, right? So please remember for which purpose we use for the which kind. So, and then metadata. What's the name of the volume I'm creating here? What's the PV name? My PV. Capacity. What's the storage? How much it is? 20 GB. And access mode, we will read, write once. Once meaning don't think it is only once, but we will read and write. And then which one we are using here? AWS Elastic Block Storage. And here, what I need to put here? Volume ID I need to put. So I'll just take the volume ID, copy it. And put the volume ID. Understood? So how to create this here? How to create a PV? kubectl create -f. Which one? PV.yml. So PV got created or not? What's the command to get the PV? kubectl get PV. So what is the name here? My PV. How much GB? 20 GB. Read, write, access. Retain. This will be there if you get deleted. Status is available. Is it bound? Did it bounded to any claim here? No. So now what we need to do? We need to create what? PVC. What we need to create here? PVC. So let's go and create a PVC here. This is a small, okay, say PVC.yml. See, Nana, again, here what is, previously we used persistent volume. Now we are using persistent volume claim. So what is the name here? My PVC. And space access mode, read, write, resources, request, storage. How much we are claiming? The actually PV is 20 GB and I'm claiming also 20. But if you wish, how much ever you want, you can claim it or not. If you want 10 GB, can you claim 10 GB? Your wish. So let's create this. kubectl create -f. Which one? PVC.yml. PVC also got created. kubectl get PV. Okay, PVC. The status is now pending. It is getting created. Why not? You can. Okay. Now let's, what we created now? We created a PV. Now first we created volumes and after that we created a PV. After that we created PVC. Now what we need to create? Pods. So then we go with the deployment and inside the deployment we need to mention what? This volume information. So see here. So VI, what do you call, is there already. We deploy, We deploy.yml. Okay, see, all these things are same. I'm just giving your PV deploy. And how many replicas? Only one. And here container name is one. Image I'm taking what? CentOS. And the command, blah, blah command I'm running. Don't worry about all these things because the concept is about the volumes. See here. Now I'm using a specification called here volumes. What is the name of the volumes I'm giving here? My PV. And what I need to do, I need to claim it or not. So what is this here? Persistent volume claim. Which is the what is the name that we have given? PVC name my-PVC. Claim name is what? My-PVC. So I have mentioned the volume information and this volume I need to mount it inside the container or not? No. This volume I am mentioning, this claim I have mentioned here. And this claim, this volume, I need to mount it inside the container. Remember, in Docker container also, we mentioned the volume and we inside the container, we mounted or not. So here also, inside the container, so I created something called volume mounts. So what is the name of the volume I'm using? My PV. And this volume, this EBS volume, we are mounting in which directory? /temp/persistent. The volume, this directory name can be anything, but I am just creating /temp/persistent. That meaning all my data will be inside this directory. So this meaning /temp/persistent meaning indirectly all the data is in my EBS volume. EBS volume will be there all the time. Parts will get deleted and created, but EBS volume will still be available. This concept is clear. Again, I'm saying here, see, all these things are same. In this, I'm mentioning what specification as volumes. So, do you call your PVC na PV na? Do you call PVC na PV na here? PVC. So, you need to go with the PVC. The claim name is what? PVC. But the name you are giving as my PV. It's okay. Name can be anything or not. This name can be anything. And the same name you need to call it here. You can give your name also, no problem. Here, the main concept here is claim. So you claim it and then you mount it. This volume, you mount it inside the container. So what is the name of the volume here you are given? My PV. So you are calling that my PV here and you are mounting in this directory. Is this clear? This volumes concept is important because we go all the time in the real time with the stateless or stateful. Stateful only, right? So you need to understand this. So PV we created outside. PVC also we created outside. And we are calling that PVC inside your manifest file. So you called your PVC here and then it will be linked all the time. So Kiran, for all replicas, it will link, right? So we created a volume here, PVC claim. And then inside the same thing, you have mounting inside the container. Online, can I get CC till here on the volumes concept? Everyone? Guys, replicas you can put 1 also, 3 also, 300 also. For every replica, the volume will be same or not? So now, save it. Okay, tell me how to create. kubectl, create -f, which one? We deploy, right? So it got created. So now how many volumes, how many pods got created? Only 1. So now it is getting created. That's right. Once it got created, what we do now here? Now we log in inside the pod. We'll go to which directory? /temp/persistent directory. There we'll create some files. Now what I do, I'll come back, I delete the pod. When I delete the pod, as I have given the replica as 1, it will recreate it or not. And when I recreate it, again we log into the pod and see the data is there or not. Same thing we'll use for databases also, same thing for application also, same thing we'll do. Yes or no? Image pull error. So image pull error. We'll take one more image there instead of CentOS. So kubectl. Let's delete it. Delete -f. Which one? We deploy. Looks like CentOS doesn't work. Here use which image? Tell me one more image. Huh? Alpine is fine. Correct no spelling? You just randomly told. Huh? Ubuntu works, huh? Okay, it's running. So here you go. What? Because it is downloading from Docker Hub, right? Yeah. So now we have the pod. Let's go and log in inside the pod. Command kubectl exec -it, and then pod name -bin. So we go inside cd/temp/persistent, and then here touch. So I'll create some sample files, 10 files. All 10 files are here. Okay. Now I exit from it. And then what I do? Delete the pod. So what's the command to delete the pod? kubectl delete pods, and then pod deleted. As the pod deleted, what will happen? It will create first it will create a new pod and then it will get deleted. So let's wait. Okay, deleted. Do you see? Now if I do kubectl get pods, new pod got created. Now let's go for exec. So I put this again. Go to cd temp/% and you see the data. Even though the pod got deleted, we have the data available. This is called stateful in Kubernetes. Understood? All the pods in real time, you go with what here? Stateful. Clear? I'll stop it here. So what are things that we have learned today? We started with metric server. Okay. After that metric server, auto scalings, and then PV. That's all, huh? Resource quotas, and then volumes concept. That's fine. It's okay. Right? So please complete these practicals, and then I gave you one task. Dashboard. Find out how to set up Kubernetes dashboard. Okay. These are things that you have for the weekend. And on Monday, we still have Kubernetes topic. Let's go over the another topics here. Right? Let's go slow. No worries and no hurry. Nothing. Okay. So exit and let's go and delete it. Command. KOps. Delete. Cluster. -, name. Just name. -, name. Yes dot k8 dot local and then -. Okay. So once you delete the cluster, remember the one more thing you need to delete. What? Volume. Volume 10 GB or 20 GB will be there all the time. So delete it. Okay. Good, Nana. So do you have any other questions? If not online, can you give the final CC for today, please? Bucket also get it. So that is all. Let's connect on Monday with the next Kubernetes topics. Until then, take care. Have a nice day. Please complete your practicals and let's connect on Monday with another topics. Okay. Have a nice weekend. Bye-bye.